Hey folks, I've had a couple of questions about exercise 2303 question 1. To be honest, I don't like this question. I think it's poorly worded. I think it's a bit confusing in the way it presents the information. And of course it can be solved, but the way when you look at it, it seems to have a little bit of conflicting information. But then this is NCA 2, so I think it's worth giving it a go. I have been advising people just to leave it if you don't get it and just move on. But just in the interests of completeness, let's just do the question and let's see if we can get what they get in the answer as well. So it says the acceleration of a particle that moves in a straight line passing through the fixed point P. So I'm going to actually draw this up. So I've got a point here. I'm going to call this point P. Particle passes through that point. And it's got an acceleration given by the formula. And it's got it in brackets, by the way. And I think the only reason is because there's meters per second squared afterwards, so you don't confuse it with multiplying it by m and then dividing by s to the power of 2. But we'll write that down anyway. So we've got a is equal to, and I won't put the brackets in because I think that is confusing. So there's our acceleration formula. And it says if the particle is initially 5 meters from P, so notice the particle isn't 5 meters from P. It's if the particle is 5 meters from P. So if it's there, I'll just draw it. There's the particle. I'll do it with a big dot. That's our particle. And that's, I'll put 5 meters here, 5 meters. So if it is 5 meters from P, it has a velocity at that point. It would have a velocity of, and has a velocity of 2 meters per second after 5 seconds. This is where the confusion comes in. The velocity here is not 2 meters per second, and 5 seconds isn't at this point. But we do know that at 5 seconds and beyond, it has a velocity of it has at 5 meters of, at 5 seconds and beyond, has velocity of 2 meters per second. So that's a little bit confusing. All right, but of course you can resolve that, and it's probably worth actually just doing that straight away. So let's just go ahead and do that. We know the acceleration, but just so this makes sense, this is not answering the question directly, by the way, but it is coming up with a velocity equation that conforms to this information. So to find velocity, you have to use this information and not just this here. So there's acceleration, but we know velocity is equal to the integral of acceleration with respect to time. So here's acceleration. So velocity, therefore, is equal to 6t minus 3. I'm leaving a bit of space around these because I'm going to increase the power by 1 and increase the power by 1. And of course, we're going to have to put a c on the end here. So let's tidy this up a little bit. So v is equal to 3t squared minus 3t plus c. Now, we do know, in order to calculate the c, that we do in fact have, at 5 seconds, velocity is 2 meters per second. So I'm going to make velocity 2, and I'm going to make t 5. So 5 here, minus 3 times 5 plus c. And of course, by doing this, we're going to end up with a c value. Let's see what that is. So 2 is equal to, 5 5s are 25, 3, so it's going to be 75. Minus 3 5s is 15 plus c. So that's going to equal, so 2 is equal to, in other words, 60 plus c. If I subtract 60 from both sides, c is going to equal negative 58. So that is the equation. We're going to say v is equal to 3t squared minus 3t minus 58. And that is our velocity equation. And that's what we're going to have to use as we go on through these. Okay, let's take a look at doing the next bit then. It says, the first bit's actually very simple. It says the acceleration after 10 seconds. Now, the acceleration, by the way, which is here, has got nothing to do with anything else. All we're going to do is simply multiply this by 10, because after 10 seconds, 6 times 10 minus 3. So let's go ahead and do that now. So this is now answering question 1a. So question 1a and we're going to find, so it says find A after 10 seconds. So A after 10 seconds, well, we know that T equals 10. We know that A equals 6T minus 3. So A is going to equal 6 times 10, just substituting that into the T value, minus 3. So A is going to equal 57 meters per second squared. And that is our answer. So that's the first bit, and that's acceleration. Or in the next video, I'll show you how we have to use this equation to find the rest of everything.